My name is Cale Ash. I'm a structural engineer. My practice focuses on buildings. I've had some questions related to bridges. I'll do my best to answer some of those if they come up. So the New Yorker article has generated a lot of interest, and especially the phrase that everything, or the operating assumption that everything west of I-5 will be toast. My office is west of I-5. Luckily, I live east of I-5. I drove a long way to get here. But I'll do what I can and see if we can answer the question, are we toast? And maybe Bob will say after me that we are toast. But I'll try to be a little more optimistic. So as a structural engineer that focuses on buildings, I think that buildings play a special role in defining our community, especially when you come to a place like Port Townsend. We each have our favorite building. I just grabbed a couple off the internet, and one of my favorites is the county courthouse. And I'll tell you why that's my favorite here in just a few slides. So Brian and Tim did a nice job, and Carrie did a nice job of kind of setting the stage for the seismic setting here in Port Townsend. We have, just offshore, we have the South Whidbey Island fault zone. Parts of downtown do have a liquefaction potential. That's this map from the Department of Natural Resources. And the other thing that's interesting, I just looked at this a couple days ago when I was preparing my slides, comparing the seismic hazard design values between Port Townsend and San Francisco. And the seismic design values here are 90% of what you design a building for in San Francisco. So, this is definitely earthquake country. And Bob may go into this a little bit too, but just to also set the stage, if we do have that South Whidbey Island fault, if we ever have an earthquake on that, these are some of the this is some of the outcomes that we could see. This is from the Washington Seismic Hazards Catalog. You can search for it on Google, and we've got about 20 scenarios on there with a lot of information about the likely effects. These are generated using a tool that FEMA has called HAZIS. So in the downtown region, could have upwards of 50 red-tagged buildings. So red tag means that after an earthquake, building officials, engineers, and trained professionals will go around and look at buildings and apply either a green, yellow, or a red placard. And just like on your stop sign, green means the building has not experienced enough damage, or is relatively undamaged. You can continue to use it. Yellow means that you can only go in under certain conditions. Maybe it's just to go in and retrieve some belongings and come back out. But red tagged, and I'll talk about this in the context of Christchurch, New Zealand. Red tag means that you cannot use the building any longer. So that if that's your residence, your place of business, that's a big impact.
What is this map? What is the red indicator?
Sure, thank you. So the map that's shown here, this is the shaking intensity predicted for a magnitude 7.4 on the South Whidbey Island fault zone. And these are intensity levels. So the red is intensity level of 8, which means there's a strong likelihood of severe damage, and then it tapers off as the colors get less warm. So another stat that jumped out at me is the fact that there could be 100 or more buildings that are likely not repairable in the downtown district, as well as significant damage to the marine and the port facility. So, in addition to the buildings that define Port Townsend, I imagine a lot of these are the economic drivers for the region. Something to think about when we're talking about recoveries. That'll kind of transition into Bob's talk at the end. A couple of the other presenters also talked about Nisqually. So I just wanted to kind of provide a frame of reference for those of us that were here at the time. I actually wasn't. I moved here in 2003, a couple years after Nisqually. Even though it was a magnitude 6.8, Brian mentioned it's very deep. It was 50 kilometers deep. This is not the big one. When we're talking about the big one, this is not it. We did see some damage. Some buildings in Seattle and kind of on poor soil conditions, or that had just the right combination of ground shaking and soil conditions, did see damage, but it was not widespread. However, if we take a field trip to Christchurch, New Zealand, and in particular the earthquake that happened on February 21st of 2011, you could consider this the big one. This is the big one for their central business district for their downtown, for their city. The effects are not as widespread as we would see from a Cascadia subduction zone, but I think this is a great chance to kind of see how some of the buildings performed in that event and how it's impacted their recovery, how it impacted their region. So this was technically an aftershock in September of 2010, about, I think it was 30 or 40 kilometers to the west of Christchurch. There was a larger earthquake. It was magnitude 7 or 7.1, something like that. So that's what defines this as an aftershock, because there was an earlier event that had a larger magnitude. It happened right around noon during lunch break on a work day, and the epicenter was located just south of downtown. 185 fatalities, and I'll come back and I'll talk about this concrete building here in just a little bit. So here's a satellite image taken of Christchurch relatively recently, and you can kind of get a scale of how much damage and how much recovery the region has to go through, and they're still going through. I talk about the central business district. I think in a slide or two I kind of show the extent of that, but it's basically a 1 square mile portion that was housed pretty much all of their high-rise buildings, a lot of businesses, hotels, all located in that area. A lot of people live in that area too. No, this is not flooded. This picture was taken, I don't know the exact date, but this just shows that this bare land, there used to be buildings there. 75% of the buildings in downtown Christchurch have or will be demolished. I think probably by now they have. The ones that were damaged and they're going to be demolished have been demolished. The financial impact is estimated at $30 billion US. Christchurch and New Zealand was heavily insured, so a lot of this money is coming into the country from reinsurers, global reinsurers. It's provided a little bit of a boost to their economy because all that money is coming in, but this is a massive effort. And I just want to point out a couple things because I'll show some pictures of these later on. This is the Christchurch Cathedral, kind of one of the poster child or one of the postcards of damage in the earthquake. And this building right here, see this one's still standing? We're going to come back. Remember that building, so I'll come back and I'll show a closer picture of it. So my company sent a team of 6 engineers to Christchurch. We do a lot of seismic design and earthquake engineering, so one of the best ways to learn is to go and see for yourself. This is almost a real laboratory for us. We were in country for about a week, and we arrived approximately 10 days after, or maybe it was about 2 weeks after the earthquake. So some of the cleanup had already happened, but there's still a lot of buildings, and we could see how they performed, what worked and what did not work. So this is a map of downtown Christchurch. The population is about 400,000, and this is what's called their central business district. Is generally this whole area defined by these 4 avenues. And the red square that's on here denotes a cordon area, an area that was fenced off, and it was staffed by the National Guard or by their civil defense because of just the intensity of damage, the risk to the public. So that means if you had a house there, a business there, you're not getting access. If you take this same 1 mile square and you overlay this on downtown Seattle, this is what it looks like. You go from the stadiums at the south all the way to Denny Way. So here's Seattle, the Seattle Center up here, and it goes from Broadway. Here's Seattle University, Swedish, all the way to the waterfront. Here's all of our, here's our hospitals. Here's Harborview. I'm not saying that downtown Seattle will be cordoned off, but this just gives you a scale of how much the impact and the area of that cordon. So here's this was my first and only time I've been in New Zealand. This picture I pulled off of the internet. This is the Christchurch Cathedral, obviously one of the landmark buildings for the city and for the South Island. And when we arrived, this is what we found. The building had experienced a little bit of damage in the September earthquake, so they had, I believe these shoring towers may have been put up before then, some buildings had some damage, and they had put up shoring towers in between September and February. But this is what we found. Here was the spire, and off to the side is that's what remains of the spire. My understanding is the building is still pretty much intact. We saw that from the picture a couple slides ago. Still trying to figure out, do they rebuild? How do they deal with this? It's a big cultural heritage site for them, so it takes a long time to sort through those decisions. So what I'll do is kind of walk through a couple of other building types as well to show how they performed in the earthquake. Here's a street view of just a typical commercial district. So this is kind of the before picture. And when we arrived, this is what we saw. So it's the same building. These are all unreinforced masonry buildings. That's what the URM acronym stands for. Typically masonry bearing walls, and timber frame construction on the inside. Pretty common construction type of the kind of late 1800s to the mid 1900s. Here's another example. Again, this is kind of the before view taken from a street view, and then when we arrived, this is what we saw. Obviously, there was probably some awnings that were hanging on here, and the streets had been cleared away, but you can get a sense of the storefronts, the defining features of these buildings have been severely damaged. Another construction type is reinforced masonry. A lot of schools and low-rise commercial type buildings are constructed using reinforced masonry. So this is the kind of the H-shaped blocks that are hollow. They stack them up, they insert reinforcing, and then grout them solid. This building actually performed reasonably well. I mean, it allowed the people to get out. It did not collapse. You would say that this all generally meets the intent of the building code, because the building code is all about life safety. Of course, this building is not economically repairable, so it was one of those buildings, part of the 75% of the downtown that has been demolished. Concrete buildings. Christchurch has a very strong and robust concrete industry. One of the poster childs, though, for the Christchurch earthquake was the CTV building. I don't know all the details. Apparently there were some design deficiencies. This thing, it was built in the mid-1980s, so typically we would think that a concrete building that's built around that vintage should perform pretty well. But as you can tell, this had 115 of the 185 fatalities were just in this one building. If you're following the news, the city of Los Angeles, I believe they are about to, or they've already passed an ordinance dealing with what are called non-ductile concrete buildings, older concrete buildings. And this is the reason why. These are really the killer buildings because they're larger, they house more people, they're heavy, and when they collapse, they tend to pancake, and they trap people, so they perform very poorly. They're a big risk to the public. Interestingly enough, Christchurch does not have a very large inventory of steel buildings. My understanding is there was a labor dispute at one point with iron workers, and structural steel as a design material kind of fell out of favor. However, I think there's some more recent buildings are being built out of structural steel. Typically, we expect these to perform pretty well, and that we saw that when we were down there. So here, this is a shopping mall just outside of that central business district. These are pictures that we took while we were there, so that the mall was operating. And you can see, here's the steel framing. We couldn't tell if there's even any damage to it. This was a reinforced concrete parking garage that had been retrofit with steel brace frames, actually a similar configuration to this. There's a little bit of distress, a little bit of yielding on the steel, but the building was standing, so it performed very well. So really the majority of the damage we saw were those unreinforced masonry buildings and a handful of concrete buildings that performed poorly. So we'll touch on a couple of other building types or more building functions. So the hospitals in Christchurch or in New Zealand, similar to practice here in the United States, hospitals and other essential services like police stations, fire stations are designed to higher design levels. We understand that hospitals are designed for about 75 to 80% higher than a normal building. This is kind of a cool building from an engineering standpoint because this uses a technology called base isolation, which means that this is the women's hospital. The whole building here sits on these rubber bearings. So there's this bearing essentially acts as a shock absorber, you could think of, or allows the ground to move below the building without transferring that motion up into the building. This was operational when we were there. We understand it remained operational during and after the earthquake. The only damage we could see is since this building is going to move around quite a bit, 1 to 2 feet, there's a moat all the way around the building, a separation. That's kind of what you can see this gray line here. There's these metal covers that bridge across that. This is the only damage we could see to this building. So well-designed, well-constructed buildings can do fine even in the big one. We did get a chance to see a couple of residential buildings. Most of our focus was on the commercial type of construction. That's what our firm does predominantly. However, we did get a chance to look in some of the neighborhoods. So here, this is similar construction that we would have here in the United States. It's a timber-framed or wood-framed building with a brick veneer. This is an older building, so it has lath and plaster ceilings and walls. And you can see the amount of damage. This residence was red tagged. We were inside of the building. We should not have been inside of the building technically, but as we did not feel that there was a risk because we know how these buildings perform. They red tagged it because of the apparent damage. The house is still standing, but this, since it's red tagged, the homeowner cannot stay in their house anymore. So that's something maybe Bob will talk about. How do we handle these people that are displaced from their homes? Okay, this doesn't show up super well, but one of the other major stories from the Christchurch earthquake is the amount of liquefaction that happened. It was widespread. It caused buildings to settle. I think some of the buildings that were demolished are ones that had differential settlement, so basically the buildings were tilting over, and they couldn't re-level the buildings. So even though the rest of the building was okay, because of that liquefaction, they've had to demolish them. But one of the stories, and this I think relates more to land use planning, is there were many, many residential neighborhoods that were built along the banks of rivers and in other locations that are susceptible to liquefaction. These all experience ground deformations, failures of below-grade utilities, think water lines, sewer lines, and there's at least 8,000, I think I've heard numbers of even up to 10,000 homes that are in these red zones that those houses are in the process of being bought out. They are not going to reoccupy those red zones because of the potential for future liquefaction. It's just not economically viable to go in and replace all of those utilities. So this may all seem a little bit bleak, but what I want to do now is show you the success of some of the buildings, even of these more vulnerable construction types, buildings that had been retrofit and performed actually quite well. So here's a satellite image, obviously taken after the earthquake, and it's uncut, so this is all contiguous. And I want to show how this building right here and this building right here performed. Similar configuration, they're both L-shaped, and they're literally 1 block away from each other. So you can see here they're similar size, similar construction type. The one on the right, especially right at that corner, in between those two wings, there were some architectural features there. You can see that the basically experienced collapse of the upper floor and really a lot of damage. I'm sure this building was also demolished afterwards. And then you can compare that to the building just a block away that has evidence of retrofit, of being strengthened. And I've got a couple closer pictures here too. So when I say evidence of this, you can see these bolts that go through and anchor the walls back to the roof structure. I like this detail. There's a little finial up here, and you can see a little piece of steel and a cable grabbing it. They're thinking about the fact that, even though we tell people to drop, cover, and hold, right, people are going to be running out of these buildings, so they're thinking about these falling hazards. But this is, very successful, nice success story. Coming back, this is the Heritage Building that I showed you in the overhead view, or showed you in that satellite image, right next to Christchurch Cathedral. We understand the story behind this. This is a federal building and had been extensively retrofit up to a very high standard. we couldn't see any damage to this building. And you can see it's right on that Christchurch Square. Buildings all around have been demolished, and this one's still there. This is probably a very expensive retrofit, but it can be done. So I want to come back a little bit closer to home, and I'll tell you why the courthouse is one of my favorite buildings in town. My firm has worked on the building for about the last 10 years, working with Gordon Ramstrom in the county on an incremental seismic upgrade of the courthouse. So you may have seen this, all of these buildings, the failures typically start at the top. It's all about how are the walls tied to the floors, especially how are those walls tied up to the roof level. So if we don't have the funds to strengthen the whole building at once, it makes sense to start at the top and work your way down. And that's what we've done working with Gordon on the courthouse. Those that live here, you probably remember seeing it scaffolded. Well, that was part of the tower upgrade. So the work that was done then is at each of these 4 turrets, each of these 4 masonry turrets on the tower, contractors center cored 6-inch diameter hole all the way down past the roof level, inserted reinforcing, and then grouted it in place. So adding some reinforcing to that masonry that previously did not have it. In addition, we're looking at details like these little strips of masonry in between the windows, the things that are really susceptible to damage. So, looking at the details, I didn't sketch it on here, but added some strong backing, added some steel angles around the clock faces to hold those in place as well. So that was the first phase. I think that was completed in the late 2000s. And then, actually, at the same time that I went down to Christchurch on the reconnaissance trip, I was working on a subsequent phase, which was, we'd already done the clock tower. Now we were working on the walls around the perimeter, the walls in the attic. And I saw buildings just like this. And as I was, designing this and laying this out, thinking about, okay, what did I learn in Christchurch? So even if there's anchors up here, we've got to reinforce around these openings. Got to make sure that there's a load path there. So this is obviously the before picture, but in the strengthening approach was putting some timber framing in there with anchors that are using epoxy that glue and secure the masonry back to the strong backing. So that's what the blue lines depict here, and then using this little platform right here as almost a floor level to help brace the mid-height of that wall. So another quick case study. This is an apartment building. This is in downtown Seattle. Usually a good sign, this is what engineers usually look for when we walk up to a masonry building, is these things that are called rosettes. These are the little steel plates. I showed you the building in Christchurch that kind of blended in with the masonry. These are painted white. You can see these are all the ties that hold the walls back to the floors of the apartment building. So some of the other features of a retrofit like this is to brace the parapets, to brace the portion of the masonry wall that sticks above the roof level. Also very susceptible to acceleration, falling, and that's what we saw in Nisqually. The bricks that came down and crushed cars. A lot of it started here, peeling off of the top. And then this is what wall anchorage looks like. It hasn't been installed yet, but gaining access to the floor system, putting in some timber blocking, and then they'll drill a hole through the wall right there and use some threaded rod to bolt it together and then tie it all into the floor. So this upgrade was performed with the intent of meeting the proposed unreinforced masonry retrofit ordinance that the city of Seattle is working on. And this would be kind of the minimum level that if that passes, San Francisco, a lot of Californian cities have already passed similar ordinances, and this is the intent of it. So just in a couple of closing thoughts here, especially in a place like Port Townsend, the beautiful historic buildings really define the community. I recommend thinking about how do we protect those so that we don't have the case like Christchurch where you're seeing large portions of a downtown region being demolished. Bob will probably comment a little bit more on this, but thinking about as a region, how do we recover? It's making sure our school children are safe, making sure that schools are a safe place for the students to be, thinking about essential services, hospitals, police, fire stations, all the things that we need to recover or need to respond right after the disaster. Think about the economy, what keeps the region going. I think one of the other lessons from Christchurch is to consider land use planning or consider geologic hazards in land use planning. Don't build on liquefiable soils if you can avoid it and if you're aware of the hazard beforehand. And I guess assuming we are toast, what goes good with toast? We better get some jam. We're going to need something to eat, so yeah. All right, that's... So I think I have time for a couple of questions.